Hello and welcome. Today we are talking about a very high precision process, boring. What is it? Boring is the mechanical process that allows you to refine and correct existing holes, improving both the dimensional precision and the quality of the internal surface. In practice, a small amount of material is removed to obtain perfect geometries and surfaces as smooth as a mirror. It is essential especially when a much higher level of precision is needed than simple drilling or boring, for example for parts that must work at high speeds or in extreme conditions. Where is it used? In the automotive, aerospace, energy and complex machinery sectors. In particular, in aerospace, tolerances in the order of a few microns are required. Here boring is not an option. It is a necessity to guarantee maximum safety and performance. Even in the energy industry, this process plays a key role. Think of the components of turbines and generators, where even the smallest error can compromise efficiency and durability. And the numbers speak for themselves, according to the UCIMU Study Center. In 2024, the use of CNC technologies in boring increased productivity by 25% compared to traditional methods, reaching impressive tolerances of plus or minus 0.002 mm. In addition, a study by Sandvik Coromant showed that thanks to new tools coated in titanium nitride and diamond, tool life increased by up to 40%, improving the quality of the finish and lowering costs. Result: even smoother surface finishes, with roughness lower than Ra 0.4 micrometers. But how many types of boring exist? Let's look at them together. Internal boring. To finish the internal diameter of a hole. External boring. To machine external cylindrical surfaces. Multiple head boring. To machine multiple points at the same time. And speaking of boring heads, fixed head, for standard machining. Adjustable head, for micrometric adjustments. Single cut head, perfect for very tight tolerances. Multi-cut head, ideal for large holes and high removal rates. Some important technical data. Accuracy up to plus or minus 0.002 mm. Feed rate from 0.05 to 0.3 mm per revolution, depending on the material. Machinable materials. Steel, light alloys. Cast iron, titanium, superalloys. But watch out for common problems. Misalignment. Stable fixing is needed. Vibrations. Better to use tools with dampers. Wear. Monitoring the tool is essential. Chip accumulation. High efficiency coolants are the solution. Practical applications. Automotive, cylinders and crankshafts. Aerospace, high precision structural parts. Energy, turbine components. Defense, highly reliable mechanical parts. And speaking of innovation, with the advent of Industry 4.0, CNC boring has evolved even further. Today, adaptive control systems adjust the machining parameters in real time. The result? Plus 20% productivity and minus 15% waste. In conclusion, boring is much more than a simple machining process. It is a guarantee of precision, efficiency, and reliability for modern industry. With CNC technologies and new materials, the future of boring is already here. If you want to learn more about other aspects of precision mechanical machining, subscribe to the channel and activate the bell.